Okay, so let's look at addition and subtraction. Okay, and then so this is going to probably be the last section for today, and subtraction of vectors. Addition and subtraction of vectors is something that is very simple, all right? Something you don't have to worry about. So we're going to look at it in two ways, okay? This addition and subtraction of vectors, we're going to look at it in two ways, and then that is going to make our work easier, okay? And so we're going to say part A of it, addition and subtraction, okay, of vectors in form of unit. Okay, so now look at it, an example, general example. Okay? Given that A equal to AXI plus AYJ, then plus AZK. Okay, now the AX, that is the X component, AY, that is the Y component, and AZ is the Z component. Now what we have, most of the times I think you've been used to the XY plane, all right, but we have we also have a third direction, or rather a third axis, which is the Z axis. Okay, so it looks something like this. Okay, so this is the Z axis, and then this is the Y axis and the X axis, like that. So this is the K is represented there. The unit vector in the direction of Z, or rather in the Z axis, is what? Is K. Okay, and the unit vector, now when we say unit vector, we are talking about a vector whose magnitude is 1. Okay, so if the magnitude of a vector is 1, then that vector is called a unit vector. Okay, a unit vector is a vector whose magnitude is 1. So a unit vector in the z-axis is represented by the letter K, okay, small letter K. And then a unit vector in the y-axis is represented by the letter J. And then a unit vector in the x-axis is represented by the letter I. Okay, now remember here, this is a right angle, and this is a right angle, and that is a right angle. I wish maybe there was a better way I can show you that. Let me try to use some illustration to explain what I'm talking about. Okay, so let's look at the corner of a building, for example. So let's try to look at something like this, and then I'll try to bring the camera like that. Okay, so if you can notice, you have that corner going up, so that in this case we can call this one as the what? The Z axis. Okay, and then we have another one going in that direction, that is the Y axis, and another one coming in this direction as the what? As the X axis. So you need to imagine something like that, an arrangement like that one, where you have a 3D kind of arrangement, where you have something going up, something going to the right, and another one to the left, like that. So this is the Z axis, you have the Y axis, and the X axis. So what you've been used to is a plane, an XY plane, meaning that it's in only two directions. Okay, it's only in two directions, but in this case, we are looking at something that is in three dimensions, or rather in 3D. Okay, so this is what we're talking about. So we have the x-axis, I mean the z-axis, the y-axis, and the x-axis. Okay, and then I've introduced a concept of unit vectors. we're saying that a unit vector is a vector whose magnitude is 1. So if you calculate the magnitude of a vector and you find that its magnitude is 1, then that vector is referred to as a unit vector. Later on we shall see, we shall talk more about unit vectors. So we are trying to look at how we can add or subtract vectors that are given in form of unit what? Vectors. When vectors are given in form of what? Unit vectors. How can we add or subtract? Okay, so that's what we want to look at. So given that A is equal to that, and B is equal to bx I, let me write it properly like that, bxi plus byj plus bzk, okay, are any two vectors. Okay, so let's say given that those are any two vectors, then we say find. So what we're going to do is, although this is not part of this segment of the lesson, okay, so we say A, although this part A and B are not part of the segment of this lesson, I want to give this one, okay, as so that we see we apply to what we're just from looking at on magnitude of a vector. So find the magnitude of A, B, find the magnitude of B, and C, find A plus B. Then D, we find A minus B. Okay. So the first two examples there, part A and part B, we are basically trying to refer them to the previous segment of our lesson on vectors, which has to do with magnitude of a vector. And then part C and part D, that is what is applying to the current segment of our lesson. Okay, so now let's look at what we have. Let's try to answer. I'm going to answer part A. All right, I'm going to answer part A. I'll leave part B to you because it is one and the same thing. What you're going to do in part A is basically the same as what you do with part B, except with the vector B. Okay, so I'm only going to answer part A, and then I'll move on to C and D. Okay, let's go ahead and try to look at that. So we know that our vector A is equal to ax I plus ayj plus azk. Okay, and then we are asked to find the magnitude of the vector A. Now, in the previous example, in the previous segment, we looked at a situation where we have a vector in the form, let's say A equal to ax I plus ayj. Okay, because it was only in two dimensions. That was the x component and the y component, right? If we are given two components only, we looked at it in the form of the Pythagoras theorem. Now, even in this case, we are basically going to apply the Pythagoras theorem, but we're going to have three components. So it doesn't change anything. The same way we had ax squared plus ay squared is the same way we're going to add another component, which is az, and we square it. So the magnitude of the vector A is going to be equal to the root of what? The root of ax squared plus ay squared plus az squared. Very simple. We put the units. Okay. In this case, it is going to be quite hard for you to apply, to find the direction, unless later on, as we proceed with the lesson or using other concepts, in physics or mathematics because it is in 3 dimensions. All right. So basically, that is how you find the magnitude of a vector in 3 dimensions when you are given 3 components ax, ay, and az. Very simple. Okay, so let's look at a plus b. So this is part C of our example. Okay, so a plus b, the vector a plus the vector b. So this is going to be equal to what? So remember our vector a was what? Ax I plus ayj plus azk. Then plus our vector b was bx I plus b yj plus b zk. Okay, so now for lack of better terms, I'm going to say we collect the like terms. Now, how do we collect the like terms in this case? We get those in the x the x component add with the x component in the other vector. The y component in one vector you add with the y component, the z component and the z component. All right. So you add them according to the components. Okay. So in other words, what we're saying is that we're going to get ax and bx. We put them together. Ax plus bx, okay, and then they should be in brackets like that, and we put the the I outside like that, plus we have ay and by, ay plus by j. Now I'm going to give an example using numbers, so don't worry. Then plus az plus bz. So we're basically collecting the like terms, isn't it? We're collecting those with x, those with y, those with z. Okay, and then we would have found if we had numbers, if we had values, we would have found the exact values of the exact value of the sum of vector A and vector B. Okay, then or rather before we proceed, is there anyone with a question on how to add vectors B? So we had A minus B, the vector A minus the vector B. So this is going to be equal to AX I plus AYJ plus AZK minus, this is going to be what? BX I plus BYJ plus BZK. Okay. Now, remember, this is a negative, this is a minus, so we can distribute this minus throughout so that we're going to have AX I plus AYJ plus AZK minus, so this minus, like I said, is being distributed throughout, so I'm going to have minus BXI minus BYJ minus BZK. So it's like we're expanding there, okay? And then this is this negative by the positive. So here it's like there's a positive there, remember? So the positive, negative by positive, it's negative. Negative by positive, it's negative. Negative by positive, it's negative. So that's the concept we're using there. And then we collect the like terms, the x, the y, and the z. So this is going to be equal to ax minus bx, and then go to the y. Remember this y here, this ay is positive, so we're going to have plus ay. All right, ay. This by is negative, so it's going to be minus by j. Then what do we have? This az is positive, so we have plus az. The bz is negative, and a k like that. Okay, so like that you would have gotten your you'd have gotten your magnitude. I mean, you'd have gotten the difference between the vector A and the vector B. Okay, so that is how you subtract and that is how you add vectors. Given that the vector A is equal to 2i minus 4j plus k, then the vector B is equal to negative 3i plus 2j, then plus 5k. Okay, we want to find the magnitude of A, the magnitude of B, the magnitude of A plus B, then A plus B and its magnitude, A minus B and its magnitude. Okay, so I want to rewrite these vectors here so that when I erase here, we're going to have somewhere to refer. So A is equal to 2i minus 4j plus k. Then our B is equal to negative 3i plus 2j plus 5k. Okay. Then, so let's look at part A. The magnitude of A, remember, is equal to the root of ax squared plus ay squared plus what? Az squared. So in this case, this is our ax, this is our ay, this is our az. All right. So you're only getting the coefficients in this. Okay. So these are coefficients. They're the ones that you are getting. You forget about the I, you forget about the J and the K. You forget about them. You only get what? The coefficients. So this is going to give us the root of ax is 2 squared plus ay is negative 4 squared, then plus az is 1, then squared. All right. So what I'm going to have, let's have that in a calculator. We have, I hope you're able to see. I want to try to put it so that you're able to see. So we have our, that is 2 squared. Let me try to work it out and then I'll show it on the camera later on. 2 squared plus, okay, 2 squared is what? Let's do this. 2 squared is equal to, this is 4 plus 16 plus what? 1. So this is going to give us 4, that is 20, plus 1, that is 21. Okay. Sorry? You're saying something? What? Where? Yes, there's a negative sign on 4, isn't it? Yes, but negative squared is what? Isn't it positive? So, you guys. So square root of 21, that is 4.58 units. Okay, 4.58 what? Units. Okay, so that is how you find the magnitude of a vector. All right. So I guess I'll not have to calculate the magnitude of B. You can do that on your own. The same way we've worked out this one. So part C, we have A plus B. So remember, this is going to be equal to, it's going to be equal to what? Let me try to use red. So we're going to have what? Our A is 2i, all right? 2i minus 4j, then plus k, plus our B is what? Negative 3i plus 2j plus 5k. Okay. Then we have to add the one with I and the one with I, that is the x component and the x component, the y component and the y component, the z component and the z component. So this is going to give us 2i plus 3i, negative 3i. So that is 2i plus negative 3i. Not so. That's what we are having. Okay, 2i plus negative 3i. That is going to give us what? So that is going to give us negative I, 2j. So this is going to give us negative 2j. Then we have k plus 5k. That is going to give us plus 6k. Okay. So we would have calculated the sum of vector A and B. Right? And then let's find the magnitude. We find the magnitude of that. So therefore, the magnitude of A plus B is going to be equal to the root of, here the coefficient there, because let's say this is the vector C. Let's call it vector C. All right. The sum of A and B, let's call it vector C. So I'm going to say this is C x squared plus C y squared plus C z squared. So this is going to give us, this is negative 1 squared plus negative 2 squared, then plus 6 squared. All right. And then this is going to give us what? This is going to give us 1 plus 2 plus 36. So this is going to give us the root of what? This is 36 plus 2, that is 38, plus 1, that is what? Oh, sorry, here it's 4. So sorry. Okay, so that is 40. So square root of 41 units. Okay, square root of 41 units. So that is the magnitude of the sum of A and B. Okay. Then let's look at part E. Yes, sure. Go ahead, ask. So if you want, you can simplify this further. You use your calculator to find the root of 41, which is going to give us 6.4. If you want, you can express it like that as the root of 6.4, okay, units. If you want, you can leave it at that. If you want, you can leave it at that. It's no problem. Is that okay?